Alright, let's take a look at this cascaded op amp circuit, and we're told to determine V naught or V output at the end of this thing here, at the end of the circuit. So again, the key here is to try to recognize the circuits that are being connected together. In this case, it's simpler than problem 5.54. In this case, we have one circuit here, right here. That's our first stage, and we'll notice that this first stage, or this first op amp, is an inverter, which is good because we know the equation for the inverter is V output is equal to minus RF over R1 times RV input. Okay, and that's all given, and we'll get back to that in a second. The second stage of this cascaded op amp circuit is that this part here, and we'll recognize this as being a summer. Okay, so this is a summer, and we know that the V output of the summer is going to be negative RF over R1 times V1 plus RF over R2 times V2. Okay, so these are the two equations we're going to be dealing with. So whenever you see circuits, thankfully these are very straightforward based on what we've defined as a summer to look like, an inverter to look like. But even if it's more complicated, always break it down into components that you recognize, and then just work your way step by step. So what we're going to need to do is find the first thing we want to do is find the V output here, and that's going to be out here, and that's what's going to lead us into the input here. All right, so just so to be on the same page here, our V output of this inverter, okay, this V output of the inverter is going to be going into, in this case, we're going to say V2 of the summer. Okay, so, and I'll let you, and it depends how you want to set it up, but that's the way I'm going to look at it. So I'm going to say that my V output here is going to be going into my V2 for the second stage of my op amp. Okay, and then you could always rename them, and I'll do that here just to for the sake of naming convention. So another way you can say is you can say, well, you can call this, if you wanted to, V1. Okay, and that would be your input there. So if you do that, then technically you wouldn't have to call this V2, you would just say V1 there. But let's just go back and let's do this convention just for the sake of simplicity and consistency with what we've had in the past. So we'll just say this is our V1. In that case, we can remove this guy and remove that guy. So we'll say our V output for the first stage is actually V1. Okay, right there. All right, so let's solve for that. So essentially, our V output here, V output is going to equal to minus our feedback resistance for this guy is 20 kilo ohms. So 20 kilo ohms over 10 kilo ohms. All right, and that's going to be times 0.4. So 2 over 1, and this is, of course, all this is minus, and this is going to give us minus 0.8 volts. Okay, so now at V1, and we're also calling this our V1 here. So at V1, this is going to be minus 0.8 volts. Okay, so now we know what V1 is going to be going into the second stage. So now we're going to use the second equation here for our summer. V out is equal to minus our feedback resistance here is going to be 40. So we got 40 over our R1. Our R1 we're going to say is 20. And V1 we said was minus what we solved for right now, 0.8. Okay, plus, again, 40 over 10 times minus 0.2 volts as our input there. Again, we're looking at the minus 0.2 volts right here. Okay, so if we do that and we solve for this, equation, we get 0.8, about 2.4 volts. All right, and that's our final output. So that's how we determine our V output. Okay, so it's pretty straightforward if you break it down. It really depends. Just make sure you're consistent with your equations and your numbers and how you make your naming convention. Once you have that set, then you should be okay. But again, that's how you solve this problem.